Hi, this video is about solving problems in freefall. First problem. An angry ex-girlfriend throws a PlayStation 5 straight down off a cliff at negative 12.7 meters per second. The PlayStation crashes in the valley below 2.90 seconds later. How tall is the cliff? So, when we're dealing with problems involving freefall, there's often a lot of implied information that's not stated explicitly in the word problem. So, for example, we do know that the initial speed was 12.7 meters per second downward, so that's a negative sign for down. We know that the time it took for it to crash against the ground was 2.90 seconds. What it doesn't say in the problem that you should always know about these types of problems is that the acceleration is negative 9.81 meters per second squared. We know this because we're assuming there's no air resistance, there's nothing to hinder free fall. Now, in reality, there probably is going to be a lot of air resistance here, or at least some, but we're going to assume for the sake of simplicity that there's no air resistance, and this would be the acceleration of the PlayStation. So the unknown here, the thing that we're trying to find is how tall the cliff is. So that's going to be a displacement measurement or a distance measurement there. And so we represent that distance measurement using the symbols delta y. Now it's not delta x in this case. You can write delta x and just out of habit and it doesn't make a difference. But typically we write y when we're dealing with vertical changes in position. X is usually reserved for the horizontal. But I'm going to write y just for the sake of consistency with what we usually use x's and y's for. So delta y is our unknown. So the equation that we need here needs to have the displacement in it, but it also should have some of these pieces as well. So this is our best bet for an equation. We have initial speed, we have time, and we have acceleration. So we substitute those values in. So initial speed is negative 12.7. Don't forget the negative sign. We threw it down. And then the time is 2.9 seconds. Kind of ran out of space here, but the acceleration and the time, don't forget the square. I wrote it really small here, but that's an easy part to forget. So make sure you square the 2.9. When you do, you get 8.41 seconds. All right, and then you also get this multiplication over here. It gave us negative 36.8 meters. Keep that negative sign there. So then we multiply all these values together. We get negative 41.3 meters. So we have negative 36.8 meters minus 41.3 meters. The displacement of the PlayStation, it went 78.1 meters down. And so that's how far the PlayStation went down. We can think about what that means translated into the cliff is 78.1 meters tall. All right, let's look at another example. During a trick shot competition, a student tosses a basketball down from a roof at a speed of 5.10 meters per second. The ball travels down 6.60 meters before landing in a basketball hoop. How fast was it going when it hits the hoop, when it goes in? So, given information, we have an initial velocity this time of 5.10 meters per second. It doesn't have a negative sign up here, but when you draw a picture and you think about what's happening, you're throwing it down, and it says down as well. So we need to insert this negative symbol here. As we're thinking about vectors, we think about direction all the time. So it's down, so we put negative. Also, the basketball moves a downward distance or displacement, and so we put a negative sign in front of the displacement as well to represent that it has moved down. These are important because our acceleration is also negative, and our equation involves vector symbols, so we need to keep track of direction at all times. So the unknown here is the final velocity. The best equation that meets all of these requirements here, we don't have a time value, so we're going to pick this equation that doesn't have time in it. And so we have final velocity squared equals initial velocity squared plus 2 times the acceleration times delta y. So substituting in our numbers, don't forget the negatives and the squares. In this case, all the negatives kind of get canceled out because we have one gets squared, the other two multiply together to make a positive. So we end up with 26.0 meters squared over second squared plus 129. That gives us 155 equal to VF squared. The final velocity is squared though, so we need to undo the square with a square root. By doing that, we get a positive or negative 12.4 meters per second for the final velocity. The ball is going down, so we know that it must be a negative velocity here. So the final velocity is negative 12.4 meters per second. So that's all I've got for you in this video. Remember, everything you have is a gift.